Bismillahirrahmanirrahim. Welcome back, dear students. I hope all of you are fine and enjoying good health. This is our 22nd lecture. And in our today's lecture, we are going to start a new chapter that is unit number 08, and this chapter is about thermal properties of matter. Students, as you know that in our previous chapter we discussed about different types of matter, and then we discussed about physical properties of matters and different terminologies that are related to matter. We discussed about pressure, we discussed about density and volume, and we discussed that how can we calculate the pressure that is acting on an object when the force and the area of that object is given. We discussed that how can we calculate the volume and the density of an object. And then later on at the end of previous chapter, we discussed about elastic bodies and we discussed about restoring force. But in this chapter, we will discuss about thermal properties of matter, such as we will discuss about temperature and heat, that what is meant by temperature and what is meant by heat, and what is the relationship between temperature and heat. And then we will discuss that how can we measure temperature and how can we measure the heat of an object. And in this lecture we will also discuss about specific heat capacity and heat capacity of an object. And we will also discuss the importance of specific heat capacity of water in our daily life. By the end of this lecture, students should be able to understand that what is the difference between the temperature and heat. Students should be able to differentiate between specific heat capacity and heat capacity of an object. And students should also be able to understand the importance of large specific heat capacity of water in our daily life. Now students, the very first topic that we are going to discuss in our today's lecture is temperature and heat. Students, when we touch a body, we feel it hot or cold. The temperature of a body tells us how hot or cold a body is. Thus, we can say that temperature of a body is the degree of hotness or coldness of the body. Students, a candle flame is hot and is said to be at high temperature. Ice, on the other hand, is cold and is said to be at low temperature. Our sense of touch is a simple way to know how hot or cold a body is. However, this temperature sense is somewhat approximation and unreliable. Moreover, it is not always safe to touch a hot body. What we need is a reliable and practicable method to determine the relative hotness or coldness of a body. To understand the concept of temperature, it is useful to understand the terms thermal contact and thermal equilibrium. Students, to store ice in summer, people wrap it with cloth or keep it in a wooden box or in thermos flask. In this way, they avoid the thermal contact of ice with its hot surroundings, otherwise ice will soon melt away. Similarly, when you place a cup of hot tea or water in a room, it cools down gradually. Does it continue cooling? It stops cooling as it reaches the room temperature. Thus, temperature determines the direction of flow of heat. Heat flows from a hot body to a cold body until thermal equilibrium is reached. Students, what happened when we touch a hot body? Take two bodies having different temperatures, bring them in contact with each other. The temperature of the hot body falls, it loses energy. This energy enters the cold body at low temperature. Cold body gains energy and its temperature rises. The transfer of energy continues till both the bodies have the same temperature. The form of energy that is transferred from a hot body to a cold body is called heat. Thus, we can say that heat is energy that is transferred from one body to the other in thermal contact with each other as a result of the difference of temperature between them. Heat is therefore called the energy in transit. Once heat enters a body, it becomes its internal energy and no longer exists as heat energy. Now students, the next topic that we are going to discuss in our today's lecture is specific heat capacity. Students, generally when a body is heated, its temperature increases. Increase in temperature of a body is found to be proportional to the amount of heat absorbed by it. Or we can say that delta Q is directly proportional to change in temperature, that is delta T. Students, it has also been observed that the quantity of heat delta Q required to raise the temperature delta T of a body is proportional to the mass of the body, or we can say that delta Q, that is the heat that is absorbed by the body, is directly proportional to the mass of the body. So students, when we combine both of these equations, then it will become like delta Q is proportional to delta T multiplied by mass of the body, that is m. Now when we write it in the form of equation, then it will become like delta Q equals to, it will become like delta Q equals to delta T dot m dot C. So students, here C is the constant of proportionality and is also known as the specific heat capacity, or simply the specific heat of the body. So when we rearrange this formula in the form of specific heat capacity C, then it will become like this: C equals to delta Q divided by m delta T. So students, from this we can define that specific heat of a substance is the amount of heat that is required to raise the temperature of 1 kilogram of mass of that substance through 1 Kelvin. So students, as you can see here in this definition, that the mass of the body is specified, that is 1 kilogram. So that's why the heat that is absorbed by this substance to raise its temperature up to 1 Kelvin is known as specific heat capacity. In SI units, mass m is measured in kilogram, heat delta Q is measured in joule, and the temperature increase delta T is taken in Kelvin. So from this we can say that the SI unit of specific heat capacity is joule per kilogram per Kelvin. Now students, we will discuss the importance of large specific heat capacity of water. Students, we know that specific heat capacity of water is 4200 joule per kilogram per Kelvin, and that of dry soil is about 810 joule per kilogram per Kelvin. As a result, the temperature of soil would increase 5 times more than the same mass of water by the same amount of heat. Thus, the temperature of land rises and falls more rapidly than that of the sea. Hence, the temperature variations from summer to winter are much smaller at places near the sea than land far away from the sea. Students, water has a large specific heat capacity. For this reason, it is very useful in storing and carrying thermal energy due to its high specific heat capacity. Students, in central heating systems, as you can see here in this picture, hot water is used to carry thermal energy through pipes from boiler to radiators. These radiators are fixed inside the house at suitable places. Students, water has large specific heat capacity. For this reason, it is very useful in storing and carrying thermal energy due to its high specific heat capacity. The cooling system of automobiles uses water to carry away unwanted thermal energy. In an automobile, large amount of heat is produced by its engine, due to which its temperature goes on increasing. The engine would cease unless it is not cooled down. Water circulating around the engine, as you can see here in this picture, it is shown by the blue colored arrows, maintains its temperature. Water absorbs unwanted thermal energy of the engine and dissipates heat through its radiator. So these are few important points of large specific heat capacity of water. Students, how much heat a body can absorb depends on many factors. So here we define a quantity called heat capacity of a body. Heat capacity of a body is the quantity of thermal energy absorbed by it for 1 Kelvin increase in its temperature. So students, you can easily compare specific heat capacity and heat capacity, because you know that in specific heat capacity the mass of the substance was specified, that was 1 kilogram. But in case of heat capacity, the amount of substance is not specified. That's why it is known as heat capacity of the body. Thus students, if the temperature of a body increases through delta T on adding delta Q amount of heat, then its heat capacity will be equal to delta Q by delta T. Or we can also write it as heat capacity equals to delta Q by delta T, and we already know the value of delta Q is mc delta T. So by putting the value of delta Q, the equation will become mc delta T divided by delta T. Delta T will be cancelled out with delta T, and the final equation of heat capacity will be like heat capacity equals to mc. Here m is the amount of substance in kilogram and c is the specific heat capacity of that body. Now students, we will solve example number 8.5, and the statement of example 8.5 is: a container has 2.5 liters of water at 20 degrees centigrade. How much heat is required to boil the water? So students, in this statement we are given the volume of the water, that is equal to 2.5 liters. Since the density of water is 100 kilogram per cubic meter, so that's why we can also say it that the density of the water is 1 kilogram per liter. That's why the mass of the water is to be considered as 2.5 kilogram in this case. And the initial temperature at which the water is given is 20 degrees centigrade. So we will say that T1 equals to 20 degrees centigrade, and we are asked to calculate the amount of heat at which the water starts boiling. So we know that the temperature at which water starts boiling is 100 degrees centigrade. So T2 will be equal to 100 degrees centigrade. So what will we do? We will calculate the difference of temperature T1 and T2, that is known as the delta T. And we also know that the specific heat capacity of the water is, that is represented by C, is equal to 4200 joule per Kelvin per kilogram. And we are asked to calculate the value of amount of heat required to raise the temperature from 20 degrees centigrade to 100 degrees centigrade. So the formula that is used to calculate the amount of heat in order to increase the temperature of the water from 20 degrees centigrade to 100 degrees centigrade is Q delta Q equals to mc delta T. mc delta T. So students, a mass is given, that is 2.5 kilogram. C is also given, that is the specific heat capacity of the water, and its value is 4200 joule per kilogram per Kelvin. And the value of delta T we can calculate by just subtracting temperature T1 from temperature T2. So by putting the values of mc and delta T in this formula, we can easily calculate the amount of heat that is required to raise the temperature of 2.5 liters of water from 20 degrees centigrade to 100 degrees centigrade. Students, this was all about today's lecture. Now I will summarize today's lecture in just 1 to 2 minutes. So in today's lecture we discussed about temperature. That temperature is the measurement of coldness or hotness of a body. And then we discussed that heat is basically the energy that is transferred from one point to another point due to the difference of temperature between these two points. And specific heat capacity is the amount of heat energy that is required to raise the temperature of a substance through 1 Kelvin. And remember that in case of specific heat capacity, the amount of substance must be equal to 1 kilogram. If the heat is increasing the temperature of a substance of 1 kilogram through 1 Kelvin, then that heat is known as the specific heat capacity. If the amount of substance is not known, then this heat is known as the heat capacity of that substance. Now students, this is your homework. You will have to learn the differences between specific heat capacity and heat capacity of an object. And you will have to learn the differences between heat and the temperature of an object. And the last question of your homework is write the importance of large specific heat capacity of water in our daily life on notebooks. Students, this is all about today's lecture. Now, if you have any question, note down that and I will answer all of your queries in Zoom session. Thank you so much and Allah Hafiz.